Hello, and thank you for joining us today on the webinar encompassing low-cost telemetry for a utility interconnection of a distributed energy resource. This webinar will have a brief introduction, introducing you to the panelists, participants. We'll cover the requirements for DER interconnection in California, which is Rule 21. And then we'll navigate to the product discussion and highlight our solution capabilities, as well as cite some specific use cases. And then we'll cover questions and answer anything that you bring up. Thank you. Next. A quick coverage of our offerings. ASE is or has been a communication solution and testing solution provider for 20 plus years. We're owned by Calcatech. Calcatech has equal experience and capabilities, and one of their offerings, or one of their multiple offerings, is the Sync solution. The Sync solution provides advanced metering capabilities in distribution, remote sites. We also have, or they also have, generation plant optimization capabilities and solutions. ASE is a manufacturer of RTUs and protocol test sets encompassing IEC 61850, DMP3, DLMS, meter test tools, and our cloud solution is Calci.io. This provides interconnectivity for IoT type solutions, both on public and private cloud solutions for electric power systems. It provides secure connectivity as well as maintenance connections and upkeep capabilities for remote devices deployed at customer locations. Calcatech provides a number of engineering services that include project engineering, product customization and implementation. We also provide custom solutions for various electric utility applications. ASE also has engineering support for development of certain solutions and features. We also provide custom training when necessary for particular protocols and testing services. Next slide, please. My name is Larry Price. I'm a customer support engineer at ASE. I've been part of the organization since 2016. A little bit about my background. I've been in SCADA for quite a few years, involved with electric utility applications encompassing AMI, AMR, outage management systems and solutions. And I'm on the front line for support, technical support and assistance with our customers. Our presenter today is Nirmal Talil. Nirmal is a product manager and marketing specialist in our IoT division. Nirmal has a number of years in the industry and has been involved with product management development for both specialized applications and products across the utility industry. Nirmal is now heavily involved with our cloud and edge projects and engineering management for those solutions. Also joining us today is Staren Joes. Staren's a director of engineering operations at ASE, has roughly 2 decades of experience in the electric utility solutions space. He's an expert in 61850 substation configuration language and protocol testing, and also provides IEC 61850 training for customers and engineers. Next slide, please. Quick background on the solution. With the rise of renewable energy initiatives, there was a need to create some regulation, and California's Rule 21 came about in July 2017. Rule 21 defines the requirements, governs the operation, control, and metering requirements for storage and generation sites that are connected to the grid, while ensuring a safety and reliability of the distribution and transmission systems across the state. Sites above 1 megawatt are required per the rule to send telemetry data to the utilities or respective utilities. The rules are specific to the IOUs in California, independently owned utilities, such as Southern California Edison, San Diego Gas and Energy, or Electric, Puget Gas and Electric. The Smart Inverter Working Group provides guidance for manufacturers. It's a collaborative effort. It identifies features required for DER site interconnection operations, etc. There are 3 current phases of implementation of Rule 21. The first phase is in process, and it identifies autonomous features required by smart inverters that are deployed across California. Phase 2, which began in 2019, identifies the protocols to be used in communications with the utilities, the DER gateways, the DER aggregators deployed out there. And phase 3, not yet in process, will add additional advanced functionality and technical requirements that are identified or needed as learned from phase 2. IEEE 1547 project is overall provides the guidelines, technical specifications, including design, construction, testing, maintenance, performance requirements for interconnected DER sites with capacity greater than 10 megawatts to a transmission grid. 1547 is a series of IEEE standards related to DER sites connected to the grid. IEEE 1547, published in 2003, is a standard for interconnection system and interconnection test requirements for DERs attached to the grid. 1547.1 is the standard for interconnection test procedures. Along with Rule 21 in California, Hawaii, and Australia, and other geographical operators are looking at DER regulations and trying to streamline the process for applicants to interconnect and provide that DER capability or add the generation capability to the existing grids. Hawaii's rules are still yet to be completely defined, just like California Rule 21. They're at the front end of the process, evaluating the solutions, identifying future needs and requirements. The same goes for AEMO of Australia. And most importantly today, I wanted to mention the fact that ASE has a low-cost telemetry gateway that provides secure and remote monitoring and management of inverter solutions deployed across California and elsewhere. We're not just deploying this solution in California, but California was one of the first locations where this need arose. So obviously we started there, but we're looking at deployments elsewhere. Without further ado, I will hand off the presentation to Nirmal.
Thank you, Larry. We start with an introduction on the requirements. So we'll walk through the Rule 21 requirements on high level, and followed by we look at the ASD DR gateway products and the solutions which is built using the DR gateway hardware. So on Rule 21 requirements, so primarily the Rule 21 on high level says all the DERs, that is distributed energy resources, above 1 megawatt, which is connecting directly to the grid, has to be monitored directly by the utility, as well as they should also have a facility to control the DERs for the distribution capacity grid services. So this is a reference architecture of DR sites where it will list what are the types of assets which will be available in each sites. In this case, you can see that there are multiple solar inverters which will be connected to a PV meter. And similarly, there could be BSS, that is the battery energy storage systems, which can be available in the site. It's a softener, which is the kind of BS meter. Again, it will be directly connected to the PCC connection point, that is point of coupling to the grid. In some cases, there could be a controllable loads as well, which can be controlled to curtail or to plug into the grid if required during an emergency. So in those cases as well, the grid load meter can also be connected and monitored by the utility. So the requirement says that this point of common coupling on the net meters or the site meter has to be monitored for telemetry purpose by the utilities in terms or ADMS applications. Primarily in this webinar, we'll be focusing on the low-cost telemetry solutions using the DR gateway, where all these assets, including the meters as well as the inverters or the DR controllers, connected to the gateway, and gateway handles all the telemetry data communication with the utility, as well as the DR control handling received from the utility and distributed to the different assets in the field. Moving on, these are the different connectivity modes at which a DR site can be connected to the utility, depending upon the DR site types. So we'll look at the different types of DR sites. Primarily, sites can have a single inverter without any load, or other type could be multiple inverters of same type, again without any load, but these inverters will be connected directly to an EMS systems or energy management systems, and the energy management system have an aggregation of all the DR assets. And third type of sites are multiple types of assets like DR inverters, BSS, or meters, and which will be aggregated by an EMS system, and EMS system will provide a single point of connectivity to the utility on IEEE 1947. Fourth type can be different types of assets again, but EMS will not aggregate all the data from different assets. Rather, there will be inverters, meters, which directly needs to be connected to a DR gateway, and the gateway has to handle multiple connections to multiple assets of different types, and provide a single 2030.5 aggregated link to the utility. So in the first case, single inverter case, it will be a single direct DR gateway will be configured or will be working as a direct client mode. In case of multiple assets with an EMS system, this will also be a direct client mode because there's only one asset in the field. In the third case, multiple types of assets and come to the EMS systems, DR gateway will be acting as an aggregator client. So in this DR gateway, you have the know-how of whatever types of assets which is installed in the field, and this will be DR gateway will be providing all these assets data as a different asset node within an aggregator client. Similarly, in the last type, with the multiple types and individual connection, DR gateways will have it work as an aggregator client and push it, send data to the system. So this is a reference architecture again for the communication requirement. There will be DR side where we multiple types of assets like site meters, VR meters, PSS meters, load meters, etc. And all these devices are capable of communicating on DMP3 or SunSpec or a standard Modbus protocol. And depending upon the meters or the make or model of the hardware which is installed in the field, you could have a serial interface or a Ethernet interface. So in whatever the case may be, the gateways which is available on the site should be able to connect with these devices over serial or Ethernet and send a telemetry data to the utility system. On the utility side, you can see that there will be a DR head end which will be acting as a 30.5 server, and the gateway will act as a 30.5 aggregator client, which will be connecting to the server and sending the telemetry data as well as receiving the DR control commands from the head end. The gateway will also be connected to the DR controller or inverters, so that the control commands which is received from the server or the utility system can be passed on to the DR controller over the standard communication media like DNP3 Modbus or SunSpec Modbus. In addition to these two systems, there could be a third-party or independent network management systems which will monitor the overall assets, gateways, network coverage, the healthiness of the assets, communication assets in the field, etc. And there will be PKI infrastructure which is defined as per the Rule 21 standard. This is the glimpse of the Rule 21 requirement for a DR interconnection. Now, moving on to the products and the solution what ASE offers. Here you can see that primary the ASE's product is the DR gateway, which is come by a single box, which is having the gateway controller, 4G modem for connecting to the internet or to the WAN network for the utility interconnection. There will be power supply for connecting that AC line power from the field, and optionally you can also have a Ethernet switch. So in case there are multiple DR assets in the field which is connecting on Ethernet protocols like the NPTCP or Modbus TCP, you can make use of the switch and connect all the assets to that switch, and switch will be connected to the gateway controller. So gateways to the field assets like EMS systems, inverters, or meters can be over different communication media like DMP3, TCP or serial, SunSpec, Modbus TCP serial, standard Modbus, could be IEEE 650 for S. And that will be the downstream from the gateway to the field devices, and for the northbound, the connection with the utility system. That will be over 30.5 aggregator client. And data will be pushed and that will be the header system, and from there it will be sent out to other applications like DAMs or VPP or SCADA systems, which is available in the utility premises. In addition to this, we also have a device management in the remote access service, which is a SaaS-based service called Calki.IU. Gateway will also have a secured tunnel with the device management service, primarily to manage the gateway devices, monitor the healthiness, monitor the communication link status, and also this service is also used for managing the device like firmware updation or configuration updation remotely over a secure link. So this is the overall solution, and the gateway is certified for CCP certification from SunSpec, and we are certified it from the authorized test laboratory, which is approved by SunSpec. And there are different hardware models and software models which has been certified for the aggregator client. And this has been tested and validated with the different types of assets like meters, inverters out there in the field. So here also you can see that gateway has been certified for all the mandatory and optional compliances requirements as defined in the CC version 2.1. For telemetry, all the functions as defined in the 30.5 and CC, time, device capability, mirror usage points, log events, subscription security, all the mandatory function set as per the 30.5 CC standard is been validated for the telemetry purpose as well as for the control purpose. For example, the function set assignment as well as response functions function set has been certified as part of this exercise. So we can look at the gateway panel in detail. Here is given out the parts which is put inside the gateway. All the gateway is NEMA for certified closure, which is having a gateway controller. This controller is primarily responsible for connecting with the DR assets through a serial link or to a Ethernet link. And in addition to that, there's a modem which we are using in GE MDS modem, which is a FastNet certified approved modem, and this is being used for connecting to the utility system or a WAN network through a 4G technology. In addition to that, the circuit breakers for protections as well as the AC/DC power supply primarily to convert the AC line from which is available in the field to power up the internal equipments, and also have the cooling fan to make sure that all devices are working in a normal temperature or given on the extreme climatic conditions. So on standard interfaces, we have got two Ethernet ports on the controller that can be extended using an additional switch which you can place here for that, so that if you have multiple DR assets, you can connect using the directly to the Ethernet ports of the controller or through a extended Ethernet switch. And two serial ports are also available for which can be configured as a 232, 485, 42 mode, depending upon the equipments which is available on the site. You can configure it and connect it directly to the controller. And there are few options of power supply available, including a standard 120 and 320 volt AC and DC that can be directly plugged in. And there's also additional power supply options available which can be provided on request. Look at the software layers. So we have gateways, the hardware gateway is being built as a secure, cyber secure devices which ensure that security has been met in all the layers, starting from the hardware. All the hardware contains the TPM, that is Trusted Platform Module, which ensures that the device always boot up in a secure mode, and which ensures that there is no malware or any other software which can be replaced on the device, and the device cannot be compromised by any third-party systems. And on top of this TPM, there's a hardened Linux and firewall and access control mechanism which is built in. It's again a strict firewall mechanism, which is firewall policy, which has been mandated in the DI gateway, primarily because these equipments have been directly connected to the internet, and all the inbound ports to the gateway is being blocked by default. It is only allowed for outbound connection directly to the utility server, as well as with the device management service called Telmetry. So that's a strict firewall policy which is being mandated and provided as part of the gateway. And on top of that, application sandboxing using Akamai and firmware signing and integrity check is an additional layer which has been built in, basically to ensure that only signed firmware which is supplied by the manufacturer can be installed in the devices. Any third-party firmware which is not signed cannot be installed on the device, to make sure that if there's no malware attack or any antivirus attacks done on the gateway. And on top of that, there's an application layer which is primarily responsible for data exchange and protocol drivers, which you see on the slides, like 3.5, Modbus, DNP3, all these protocols drivers, which is responsible for collecting and exchanging data with the field devices. And there's also data logging module in case if you want to log the data on a permanent storage, you can do that. Configure it for logging it for a few days or a few entries as required. And data exchange layer also provides the interface to the diagnostic and logging, primarily to send out the diagnostic information, log information for the troubleshooting purposes primarily. And there's identity management services, ensure that all the device access will be secured using a role-based access control, which is being provided by Calculator device management service. Move on. So on the PKI infrastructure management, which is being followed by the gateway. So primarily these gateways have three trust chain of PKI infrastructure. Trust chain one is manufacturers, that's ASCs or architects trust chain. Primarily, this trust chain is this is not installable. This mandates that any firmware, any software which is or patches or license being installed on the devices will be signed using this PKI infrastructure trust chain, so that any third-party software cannot be directly installed on the devices and compromise the system. The second PKI infrastructure is installable. That is primarily used for the device management, and this is private. So in case a user has got their own PKI infrastructure, they can bring in that trust chain from there and install that trust chain into the devices, so that the device management access will be through the user's PKI, and this makes sure that the role-based access control to the devices is ensured, and only the privileged user can access the devices and do any configuration updates or firmware updates depending upon the user's privileges. So that's the PKI 2. And PKI 3 is primarily issued by Rule 21 PKI infrastructure, which is being provided by the SIWG approved labs or approved certification authorities, IEEE. And primarily this is installable. You can install the PK root and PK infrastructure in the gateway to this is used for to establish the 30.5 connection with the DR head. So that's the three PK infrastructure which is supported on the devices. Talking about the protocols, so just classify the protocols depending upon the interfaces or use case where it is used. For utility interconnection gateways, always supports 30.5. In addition to that, if utility wants data in other protocols like DNP3 or 6150 or 60870, 101, 104, or ICCP, that's interconnection protocols, or 614.000-25 for the wind farms. So all these protocols are also supported in case if you have to have two different connectivity to the utility interfaces or to the northbound applications, that is possible. For the DR connectivity, primarily as follows with the IEEE 1547 and IEEE 1547 list few set of protocols like 823.5, Sunspec, Modbus, DNP3, etc. So all these defined protocols as per the 1547 is supported in the gateway for the DR connectivity. In addition to that, gateway also has support the IEC 61850, primarily based upon the 90-7 object model for the DR, and DLMS custom for the meters, net meters, or the other PV meters which is installed in the field. Backend ones are also supported in case if that other devices or equipments which is compliant to any of the standards can directly to the gateway, and the gateway can translate these protocols into 30.5 or to utility interconnection. On the IoT platform connectivity, there are different options available, like standard options like OPC UA or impurity are available. In case if you want to send it out to your IoT platforms, if you have any standard proprietary or any standard IoT platforms out there, you can share the same data with your system as well, in addition to the utility interconnection. So we also have native connectors to Amazon and Microsoft Azure, so you can directly connect with the AWS IoT Core through Wingdas to IoT site price and Kinesis data streams. And the Microsoft Azure, you can directly connect to the IoT Hub, and Azure IoT Edge is also available. The entire gateway can be made available as an IoT Edge module, so that this module can be plugged into any of the edge devices and share data with the Azure platform as well. And for the management, there are different interfaces like SNMP for the connecting data from the field equipments like routers, switches, etc. out there in the field. That those status and diagnostic information from those equipments can be collected. NTP, SNTP for time synchronization of these the gateways as well as other equipments can be done because of the NTP and SNTP services. The client and server services both are available. So in case you want to synchronize the gateway time from an external source, you can do that, or if you want to synchronize the other equipments from the gateway time, that's also possible. And there are other time synchronization options like PTP or NMEA or XP are also available, and other management interface like SMTP or TCP can be configured to push out data. So talking about the different protocols, the gateway needs to have a flexible data mapping option. So in this example, you can see that there are different types of equipments out there, which is communicating on different protocols, and the same data needs to be shared with external systems, two external systems. One is on 30.5 to a DR head, and the other is a SCADA system, which is on the DNP3. So the gateway should have the flexibility to map. We can choose each and every data models. This is a Sunspec model. Device model should be mapped to a 30.5 as well as to DNP3. or it could be a EMS systems or inverters or any other RTUs out there which can communicate on the MP3, and you should be able to pick up the data from these devices or the MP3 and map it to a non-bound communication interface. Similarly, there could be devices with IEC system FT, and system FT logical nodes and logical device stacks has to be mapped to a 2030.5 or MP3. So the mapping framework of the gateway is flexible, so that you can ensure there's a multi-protocol mapping. You can map the same data to different systems using a master to slave mapping. So this is the master interfaces, which is responsible for collecting data from the field devices. And this is slave or server interface, which is responsible for giving out data to external systems. So default often is master to slave mapping. You can map the master to a slave, so that data from the field devices can go directly to the SCADA systems or ADM systems. And in addition to that, the framework also provides flexibility to map master to master system mapping. This is primarily used for getting data from the field through a master protocol like a Modbus, getting inverter data from Modbus and sending to an RTU over the MP3. You can do a master to master mapping here, and inverter data can be directly sent to as a command to the RTU. Similarly, slave to slave mapping is also supported. Like if you have SCADA systems on the MP3 and a DR hadn't done the deployment file, SCADA needs to send out the system. You have a slave to slave mapping, and the commands from the MP3 will be redirected within the deployment file data, turn to data to the DEM system. So that's the flexible mapping option. In addition to that, we also have the device model specific mapping, especially in case of SunSpec Modbus. All the equipments which is certified for SunSpec has got a defined set of models which is available. You can pick those devices from our standard library and add those devices and actually automatically map it within the 30.5 client, so that it can be pushed to the data can be integrated with the utility. So the engineering is much easy with device specific model mapping, and that kind of flexibility is also provided in addition to the point wise mapping which you have seen in the earlier slide. For the monitoring of the gateways, so as I was explaining in the earlier architecture, there is a device management and device monitoring service, which is a hosted service. It's called Kalki.io. So using Kalki.io, you can monitor the devices, gateway healthiness, how many gateways are healthy or available. You can also monitor the communication with the utility. Each gateway's 2030.5 connectivity, which how many gateways are healthy, and also the DR end device communication from the gateway to the meters or the inverters. Communication can be monitored from the device management portal, and also other parameters like the gateways CPU usage, etc., and alarms can also be monitored from the dashboard. And the modems, as I mentioned, there's an external modem, which is a GE modem, and it also needs to monitor the network status, the network signal strength, power quality, and the signal power. So those parameters can also be monitored from a central system through the dashboard. And you can have a dashboard-based configuration, or you can have configured reports, and it will generate a report on daily basis or on weekly as per the user configurable. And the reports can be sent out as an email or to as a PDF or the Excel file to configured recipients. So that's on the monitoring side, and you can also do the role-based remote management of the devices. Like you want to update the firmware, update the configurations. So those can be done through a role-based access control. Again, that is through the California IOU's portal, which is provided. And going details of the device management layer. So it's a secured remote management layer where the gateways are connected directly to the Kalki.io device management service through a secure TLS tunnel. And this tunnel is being created through a certificate which has been pre-installed on the gateway. This is a under certificate, not the 2034 certificate. This is a device management certificate client authentication using which it will create a secure TLS tunnel with device management portal, and through the tunnel user can do all the management use cases like the updation of firmware configurations, etc. And the role-based access control is been validated through two different modes that is also configurable by admin. You can either select a online mode using OCSP, or you can also go for attribute certificate based mode, which is primarily offline mode, which attribute certificate is being issued to each user for each devices, and it is as per the IEC 62351-8. That's the role-based access control standard defined in the 62351. So that's about the security which is being ensured the device management from a Kalki.io from a remote location. And in addition to the gateway remote management, you can also have remote access or the field devices, like for example the inverters which is coming to the gateways. So this is an additional use case which will be useful for a developer or to the site maintenance engineers or the OEMs. If you want to access the gateway without traveling to the site, the gateway provides a secure tunnel through the Kalki management layer. And technicians who log into the Kalki.io web portal can create a secure link from the remote PC to the site, and from site it will be directly connected to the inverters or the EMS systems, and to the configurations of firmware updates of these field devices as well through the secure tunnel extended by the gateway. So that's also an additional functionalities which has been provided by the gateway and the Kalki management layer. And here you can see that all the because of the strict firewall policy, there is no inbound connection allowed from any other users to the gateway. Only the inbound connection will be through the secure tunnel, and this tunnel will be created from the gateway using the client authentication page, which is pre-installed. And gateway will create a outbound connection from the device, from the field to the Kalki.io, and create a TLS 1.3 tunnel. And the remote access will be through the tunnel, so that to ensure that nobody from the external network or WAN network or internet can directly connect to the gateway and access these field devices. So moving on. So how the products are packaged. So the products which is supplied primarily has got the DR gateway, edge gateway, this HVT controller, NEMA, which has been mounted inside a NEMA board enclosure, and which will have a universal power supply, which is primarily used for connecting the AC supply available in the field, and which also there's also GE MDA cellular modem, which is primarily used for providing the internet to the gateway as compliant to 4G LTE, and modem has been certified for the FlashNet. So we also include the AT&T fixed AT&T SIM card with a fixed IP. This is also packaged as part of the product, and SunSpike Curio certificate to establish connectivity with the utility server is also provided. So this is the full product package, which includes hardware, certificates, SIM cards, and the network cellular network for the connectivity server is also included. On the product support, as part of the standard product, we have standard premium support for 20 hours for supporting customers to remotely configure the devices for the field devices. And also we have a program for pre-engineer the gateway before shipping out to the field. So you can share us the type of equipments which is already installed on the site. To share the list of the equipments and the details, you can pre-engineer the gateway before we ship out the device to the site. And also provide an online training if user wants to do the engineering by themselves. An online training and additional supports can be provided on. And for maintenance, there's a subscription, maintenance subscription can be extended for total 5 years. And in case more than 5 years is required, we can provide extension beyond 5 years as well. And with the maintenance, you have access to the management portal, which is IOU's web portal, where you can do the monitoring of the gateways, management of the gateways, like firmware updation, configuration updation of the devices, patches, security patches. All these deployments can be done through the management portal, which is also available as part of the maintenance subscription. And you can also provide a 50 MB cellular data per plan as part of the SIM card. Default 50 MB will be available as part of the maintenance subscription is done. And data usage is more than 50 MB, that will be available, charged on pro data basis, depending upon the usage. So this is the overall packaging of the ASC's DR gateways. With this, I would like to stop here and moving on to the case study, which my colleague Sterin will walk you through. Sterin, over to you.
Yeah, thanks, Nirmal, for the detailed presentation and product overview, which includes a lot of details. And thanks, Larry, for the introduction during the initial part of the presentation. So during this part of the webinar, we will try to cover the DR gateway installation at a customer location. We will share the details of the initial deployment phases and how we dealt with the first pilot project, which was done at PG&E. Yeah, move to the next slide, please. Okay, so as you see here, we installed this DR gateway in one of the California location, and this was done at Bloom Energy location, and the customer was Form Factor. So the requirement was to connect 2 meters, one PCC meter, which was Mark 5 meter, and another PV meter, which was the manufacturer was Activate. So from these meters, the data had to be collected into the DR gateway. With Mark 5 meter, we collected data through Modbus TCP. So gateway has a LAN port, and using that port, we could connect to any TCP device like DNP3 or Modbus or any other standard protocol. We could get the data into the gateway. So we utilize that functionality to configure the gateway to match with the network addressing of the site, and collected the data from the Modbus device. And on the other side, we collected the data through Modbus serial. And for this data collection mode, we used RS-485, and this accumumeter support RS-485. And our DR gateway supports 2 ports. Both can be configured to either RS-232 or RS-485. So we utilized the configuration capability of the DR gateway and used the second port, that is the default RS-485 port shipped from the factory. So we utilized that connectivity to get the data through Modbus serial. And from there, we have a connection to the modem, and the modem exposes the gateway using a fixed IP. This is as per the PG&E specification that for the whitelisting purposes, the modem need to register to the PG&E server using a public static IP address. So we registered our modem into the network, and using the 2030.5 standard, the modem will be enabled with the certificate, and it will make connections to the server. And based on the whitelisting done in the server and firewall rules done in the server, it will allow connections from the modem. Since it has the whitelisting done, it will make the connection, and from there we enable the communication, through the 23.5 channel. So in summary, downstream we are collecting data through Modbus TCP and Modbus serial, and to the utility side, to PG&E side, we are pushing data through 23.5 protocol. So that's the kind of high-level summary of this data transaction. And here we are using aggregator client capability of DR gateway. So as Nirmal mentioned earlier, the DR gateway can be configured as a direct client or aggregator client. Since we had 2 meters in the downstream, we used aggregator client capability and use that configuration mode to get the data into utility data center. Next slide, please. This is the picture taken at the Bloom Energy site, and here you can see that the DR gateway enclosure is separately mounted on these poles, and there are conduits run below the gateway to run the cables. There are communication cables required. One is Cat5 or Cat6 cables to allow the network communication, and further the serial communication channels also to be required for RS485, and the power cable power connections are also required. So all these cables are run through the conduit and poles, and the DR gateway is mounted separately and locked and secured at the location. Next slide, please. So the step adopted for installation and maintenance, I'll go through the phases of this project. So since this was the first project done at PG&E location, we had a detailed process for the data collection. We had to find out which all meters will be available downstream, and how the meter connections will happen, whether it is through TCP or serial, and what are the serial port parameters and what are the TCP networking parameters. We had to collect all those information. And once the meters are identified, we also collected the IO list of those meters for the Modbus mapping. We could collect data through SunSpec, DNP3, or Modbus, or any other standard protocols. But in this case, it was Modbus, normal Modbus protocol. So we used the data sheets and details from the manufacturer to configure the gateway. And the next part was the pre-engineering of the DR gateway using our configuration tool. We have a standard SyncConnect configuration tool to configure the gateways. So we utilized its capability to create meter templates and information into the SyncConnect tool. And from there, we have mapped all the information into 23.5 protocol. As Nirmal mentioned earlier, we support any-to-any mapping of protocols. So in this case, we utilized the capability of Modbus to 23.5 mapping. Once the configuration was done, we shipped the device to the site. We delivered with all the information. We provided the configuration utility as a software package to the customer, and we also provided the device management account. So as part of the standard delivery, we provide all this information to the customer. And in a typical scenario, we handle the device management at our location, like ASC engineers will be handling the device management or monitoring of the device, and customer also will be provided an account to monitor the system. And as part of the installation and support, we had to, since it is a pilot project, we had to get into the details of how the deployment will be executed. Customer, in this case, Bloom Energy could install the gateway at the site, make the wiring and connections into the meters, and set up everything. The power connections were set up. And once that was done, we had a detailed discussion and SCADA testing phase. So that means once we verified the data from the meters, we established a connection to the PG&E server. The whitelisting was done, and based on that, we could verify the data. The good thing is that through the remote management server, we could access the device through the secure channel, and we could monitor the system as good as the local access, right? So we could provide all kind of remote support to make sure that the device is up and running and getting the data and sharing with the PG&E server. From a maintenance perspective, we do the device and communication monitoring, and we have internal mechanisms in place to send the notification to the customer and to the responsible people here. So all the disconnections and connections will be notified through email, and if there is any configuration or firmware updates are required, we will do that as well. Next slide, please. Yeah. So I would like to highlight on the remote management and firmware update capabilities done for this project. So as I mentioned earlier, ASC assisted customer to complete the commissioning process. We have a two-step process here. One is the verification of data communication with the meters. These are the downstream devices from where we get the data through Modbus in this case. And we also need to verify the data upload or push into the PG&E server. So both sides we verify and we assist the customer to go through this process. And we also monitor the status and events reported by the gateway. So gateway has a secure channel into the management server along with the PG&E server. So as gateway push data to the PG&E server, it also sends basic status information and other health information to the remote management server. So we can monitor information there. We also developed features that would improve the data exchange and reconnection methods in case of communication failure. So there are two scenarios here. One is the data posting rate in this case was 30 seconds. So that means telemetry data need to be collected from the meters and need to be sent to the PG&E side in every 30 seconds. So we had to deal with some of the data rate requirement from customers. So that means if we relax the data usage, then the data rate or SIM card charges will be kind of on a higher side. So we improve the data exchange and mechanisms so to make sure that data rate used by customer is minimal. And for this use case, we used a 3 GB plan for a month. That means that's a typical data usage we see in California based on the data posting rate specified by PG&E. In every 30-second, data need to be posted, and this comes around like 2 GB plus. So we have enabled customers for 3 GB plan, monthly plan, so that they can meet the utility requirement. And there are some optimizations done on the reconnection aspects as well. So that means if the connection is dropped due to cellular networking scenarios or a server reconnection or reconfiguration phases, then the restart of the server will cause a disconnection. Our cellular network disruptions also will cause disconnections at DR gateway side, right? So to handle that, we have improved our reconnection methodology to keep the downtime as minimal as possible. We have, we have implemented all these capabilities as part of the pilot and deployed them at the site. So on the firmware update side also, we had to do the remote updates. As you can see, these features were developed after the deployment, and we could deploy the firmware into the device over the air. That means we have a secure connection to our remote management server, and we push the firmware and update our field devices. So all the security updates of the Linux and firmware updates of protocol engine both can be updated remotely through our management portal. Next slide, please. So in this slide, I would like to summarize the life cycle, installation, and maintenance of this DR gateway. So initial part comes in the form of support. That means we will have access to the IOU, so that's staging support, access to, we will have certain capabilities provided to the customers to access the portal. And during the development phase, that's what we focus for. We have in our internal testing, we make sure that we run the simulation, and we closely replicate the meters at our location, like whatever meter we have, we create the Modbus or Sunspec Modbus or DNP3 simulations at our facility and perform the configuration and simulation. So once the gateway is shipped, it is ready to deploy mostly. And we have a development process that takes care of the roadmap of the product, where we cover all the ongoing developments of the protocol. And if there is a new standard coming up, like 1547 variations or improvements, we take care of those changes as part of our roadmap planning, and we include them. And once that is implemented, we could send the firmware update to the devices, so that it is updated to all our devices and keep them up to date. And on remote support, we will focus on the DR customers who basically can purchase our subscription plans, and using this methodology, they can keep the installations and maintenance of the gateway intact. So we provide, we have a team of engineers who monitor the system using our IOU portals, and we'll be providing all the necessary support to our customers to keep the installation ready and maintenance ongoing. And we have a standard customer support process to handle the queries or change request, or if there is a hardware failure, which typically doesn't happen, but in case of such mishaps, we also have a process in place to take care of the RMA and provide necessary supports on those aspects. Yeah, that's I think that covered most of the details. I think we ran out of time, like 3 minutes. So I think with this we will summarize our webinar. Maybe we can get into the question and answers, right? And then, well, do we have time for that?
Yeah, have a couple of questions. So presenting.
So Larry, do we have any questions at this point? Audience?
Yes, sorry, I didn't hear the last. The first question is, how is network coverage ensured with the device or solution? As far as cellular network coverage.
Okay, yeah. So Nirmal, would you like to answer?
Yeah, go ahead. Yeah, please go ahead, sir.
Okay, so we generally do a site verification. That means based on the network provider. In this case, we are utilizing AT&T, and using AT&T's network map, we verify that the network coverage is available on a certain location. And we also provide the details of the signal detectors to customers. There are standard mobile signal detectors available in the market, which we could utilize, and we provide the details to customers, and they can verify the signal strength at the specific location. But generally, what we have seen is that based on the network mapping, most of the informations are accurate, and using our standard accessories like antenna, we will be able to get the same signal as customers specifies. So that's what we have seen, but we could do the separate online and on-site signal strength analysis if required.
And can we use our own router or modem at the site?
Yeah. So on this query, it is possible to use customer specific modem or the SIM card, But here PG&E has a requirement that it need to have the fixed static IP address. This requirement may not be easily met by many of the customers. So we have a agreement with AT&T, and using this mechanism, we are providing fixed static IP address for PG&E's whitelisting. So that is one requirement, and we also have a firewall in the modem. So this firewall is pretty standard in GE modems, and we utilize that firewall rules to make sure that only standard whitelisted IPs are allowed to communicate. So we will require those capabilities in the modem before before allowing the gateway to work with that modem. So yeah, there are two aspects. One is then from the network provider, we need to have certain requirements, and from modem side and routing table configuration side and firewall side, we need to meet certain restriction. So we mostly go through that standard certification process. We work with the customer and verify that the modem meets all these requirements, and based on that we can provide, we can work with customer to use their modem.
And next question. Many sites have a standard power supply using 277 volt service. Does your product support this range?
Yeah, so here we have seen different requirements. One is the standard power supply requirements in North America, 110 or 120 volt AC. That's one type of requirement we have seen. And other scenario we have seen is that in some DR locations, we have seen 277 volt AC as a standard requirement. And recently we also found that we have a requirement for 347 or 340 range power supplies. So to meet all these requirements in the latest revision of DR gateway, we have included two power supplies. One is the universal power supply, which is from 85 to 64, and we also have another range which is 180 to 550 volt AC. So using these two power supply, we will be able to meet all the requirements from the industry.
Very good. And from a network management perspective, are the monitoring dashboards just canned, or are they customizable from an end user perspective?
Nirmal, will you be able to answer that question since it is related to California IOU portal?
Yeah, so the dashboards and reports for monitoring the devices is customizable. You can have different widgets configured for showing the health status and the computer status details. Yes.
And lastly, is there any data logging capability for performance assessment?
Yeah, so here Gateway comes with a very detailed traffic logging and offline logging capabilities. So the basic feature we have is the traffic monitoring feature, where the data traffic between all the downstream and upstream communication can be monitored online. So this is this data is not served to the gateway as it is kind of mostly for the troubleshooting purpose. We have a traffic monitoring feature. Once this phase is done, we also have a capability to log the traffic offline into the device. So we have a pretty good storage. Most of the shipments are done with the 64 GB SSD or 32 GB SSDs. So that means we have a lot of storage in the device to meet this requirement. So we allow configurable range of log size in the gateway, so that if there is a need, we could enable detailed logging, and we can capture enough data as possible. And on California IOU side, we push the connection details to the California IOU on periodic basis, and we have a log there to see when the gateway was connected and disconnected and so on. And we also can log the information, like since we are sending the signal strength and other information to the Calcaio portal, we could also have a history of that information. Yeah, so these are the different options available in the DR gateway logging capabilities.
Thank you. That's the end of my questions.
Okay, so Nirmal and Larry, shall we wind up, since if we don't have any other questions, probably we can
Yes.
wind up, and we have already consumed 10 additional minutes. Okay.
Thank you all for your time for this webinar. So we have found out a few more questions lined up. We will send the response for that by email since we are already over time. Thank you all.
Okay, thank you.
Thank you.